Okay, audio check. 1, 2, 3. Okay, sounds good. Ladies and gentlemen, this is the Discourager of Hesitancy. Welcome to the stream. And let's get started. So, we're in the polishing phase of this project, and we hope to upgrade from crappy programmer art to just mediocre programmer art with proper layout and so forth. And to that end, we started laying things out last time after we finished the last technical task we needed. And frankly, I'm not real happy with any of the results yet, and it takes me longer to get things done art-wise than anybody else, so we're just going to keep stumbling along and try to get some art going. Pat, sitting here playing Kaizo, and I hear check 1, 2. Nice. Hopefully I didn't interrupt your concentration. So, I'm debating if I should change my topic. This isn't really software and game development. This is more like art and game development, but do I change it to art? Is that a thing I should do? Maybe we'll draw in some unsuspecting people to watch the stream. So this is kind of where we're at. Let's see. Okay. What I need is I need GIMP backup. I think that's where we're going to spend some quality time today. My printer's broken, so my plan is got to change a little bit. We're going to probably do more GIMP than I wanted, but that's okay, or something. Art relating to game development is still programming and game development. Okay, I'm fine with that. I'm okay with that. I just don't want to get in trouble. People show up and be like, "Oh, it's not programming." If they came in any other week, that's what we would be doing. All right. So we were kind of laying things out and have an isometric grid. And I think these are reasonable. Let's see. Yeah, it looks fine on Twitch, I guess. Maybe we could zoom control. Until it's getting colder. Just, oh, yeah. I had to walk down to a meeting this morning, so I'm actually getting warm in my office finally. It's warming up here. But yeah, it is cooling off. It's nice. I like it cool. Yep. I like cooler weather more than I like hot weather. Good, good. Yes. Jersey, I believe, gets plenty cold. All right. So where do I want to start? Monowidth font. Do I have any good monowidth fonts? Like a courier or something? Oh wow, this is like the worst interface ever. Can't type in a name. Courier. Okay. I'm actually gonna put this pretty close to this. I always say you can always put more layers on. Once you get to that last layer, you're screwed if you're still hot. Yep, yep. That's pretty much how I say it. It's I can always put more layers on, but eventually you can only tick off so many before they get you for indecent exposure, so. Same idea. Where to begin? So let's see, I can grab this layer. Come on. Oh, come on. What is going on here? There we go. I can line up that isometric line. So what if we put a line here? The difference in the lines is 250 to 260. 10 pixels? Wow. So from the top of a word and up 10. So that's 215, so 205. This line is at 267, so we come over to 277. This number is 454 to 464. So that's kind of the blocks. I actually want the text spacing to be a bit more if it can. Or, okay, here's an idea. I need. Is this GIMP? Yes, this is GIMP. Never used the 3D aspect of GIMP before. There is no 3D aspect of GIMP. We're faking it. This is called an isometric grid. A lot of old games are in isometric. In fact, a lot of modern games are too. But your old Diablos and your PoE, Grim Dawn. Basically means we fake it so it looks like it has perspective without ever getting the perspective distortion. All the lines remain parallel. there are layers, but we cannot do 3D here. So maybe what I should do, is hide the GIMP. We go into the game. Let me get one of our words up here. Prime is probably fine. I'm gonna print screen it. Because this is the font we're probably gonna use. Print screen. Then back over to GIMP. Instead of using this word, move this layer. We need a crop tool. We need to crop the current layer only. Let's scale that layer up to, well, prime, duplicate layer, hide the original. We will scale this new one. Where is it? Scale layer. Make it 50 pixels high. So 1, 2, oh. 1, 2. Right, then we move it right about there. Oh. Hmm. Thought it was like the same as with Photoshop. Photoshop has a 3D mode where you can actually edit 3D models and stuff. Oh, I've not tried that. I knew they had some 3D and fake 3D kinds of operations, but I don't think GIMP does. And my GIMP is very out of date, so if they do have that, I don't have it. I don't update my software until I have to. So the idea is that we can make 5 evenly spaced blocks around this stuff. So what is this? 277. Well, I like the idea of like school blocks, like the kids' blocks up top. So the distance from 277 to 314 actually. Do I just cheat? Is that a thing I don't want to do? I should have done. It's fine. It's fine. If we select this, new layer, sure. We fill this. We come over 2 pixels. 1, 2. Paste. Nope, not that one. I always forget what I'm doing here. Okay, so we're going to duplicate, move. Turn the opacity down so we can see where those blocks are. Yeah, our letter spacing is going to be off. But that may be okay. I have the ability to change letter spacings later. 1, 2. How big are these rectangles? 37 by 35. This probably 1, 2. Probably me being too picky. 37 by 37. I wonder if I should allow sub-pixel character spacings. I think that would be easy for us to change. But we just go 37, 37. They're definitely taking up more room than quite originally planned, but that's probably okay. We do want our fonts to be large-ish and readable in the game, so 37, 37. So the word prime. What if we went 35, 35? Come down 1, 2 pixels, 1, 2 pixels, 1, 2 pixels. 1, 2. That's a 35 by 35. Five by 35. Two. 2. 35, 35. Bucket. Okay, that looks a little bit more reasonable. So we grab layer 2. We can even hide this thing. If this is where we decide the letters go, oops, it did not listen to me. 1, 2, 3, 4, 5, 4. Kind of feel like that's where we want our blocks. Now, one, two, three, four, five, six. One, two, three, four, five, six. Let me space the blocks more. Let me see. If we split this thing, so what's the number here? Is that pixel 20, right? All the way to the other end of the bookcase is 762. So it's 742 pixels wide. If we split that in half, that's 350, 60, 71, 371. So 371 is the midpoint line of the bookshelf. And we need to fit this layer neatly. Oh, +2. We can center this one later, but what we need, this is why we're stubbing things out with rough colors. When it goes into a column, it needs 2 more spaces. Let's go back to layer 1. And delete it. Layer 2, copy, paste. Oh yeah, 2 new layer. So we can delete layer 1. This pasted layer is what our words actually look like. So we need 1, 2. Another 35 by, oh, come on. Another 35 by 35 pixel region. Thank you, guidelines. Bucket. One, 2. $35 by 35. Okay, so what this is guess blocks. This is guess blocks 2. Layer crop to content. Yeah. Crop to content. Make it smaller. Current guess. There we go. Now the guess blocks. Need to both fit. So the width of the bookcase right now is 742. Bookcase 742 by what's our y-axis here? 260. All the way down to 1420 if I'm not mistaken. Yep. Let me subtract those. 3, 12, 6, 1, 1, 6. So our bookcase is 742 by 1160. So when we take 742 divided by 7, that's like 100 pixels, but we need book shelving on the left, right, and down the middle. So we can actually pick something that divides nicely. So 742 minus 3 somethings minus 14 something else's. We just want X and Y to be. So let's see here. Let's go over to the thing. Dravest, good afternoon. So far, so good. We're probably doing way more math than artists are usually want to do because I much prefer doing math to art. So that's what we're doing. So we could let's see here. And how are you doing, Dravest? So the bookcase I have at 742 by 1160. That's the total area I can work with. Now, there is a left and right and a center vertical. there is the depth. We have to take into account, and then there are 14 characters across. So we can just plug in numbers. We can say something like 3 times, I don't know, what do you call it, 10 pixels? The depth will be, we decide how many pixels is a meter. We make a bookshelf 2 meters wide, we make it a meter deep. So 371 pixels. That's on the weird angle. Let's just make something up for now. We're going to add all these up. These are all the things that make up our width. Plus 14 times 35. Oh, times 14 and 35. Yes, thank you. Spaces. So that's 640. We have 742. So one question is 371 times cosine of 120. Do not remember. Times 371 pixels per meter. I just want to know. 302. I guess I did calculate it. So this is wider than the target for the bookshelf. I like having a good sized margin, but maybe 10 is a little bit generous. Maybe if we go with like a 7. If the bookshelf is not a meter deep, what if it's only half a meter deep? That actually buys us quite a lot of space, probably. 662. 671. So maybe we can go just a little bit bigger then. Maybe we can go to 37. 38. The bigger the letters, the better. 39. Make our blocks 40 big. There. So this will be 10 pixels for that. The depth will be this mess. Horizontal depth. Which is 151. And then these are 40 pixels. This is all horizontal though. Okay. Oh, nice. Good, thanks. Had some good meetings today, just doing some back-end dev. Good, good. Your contract is progressing nicely, I hope. We could put all of this into a table. Oh well. So vertical spacing, let's just say 10 pixels top and bottom. Um, 5 pixels for each shelf. So if we look at this thing, come on, where did they go? There we go. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 of those. So times 9. Then there's the space the characters need, which I said is 40. 10 characters, 10 words. So if we add all this up, plus we have times 2 times 10 for the pixels at the top and bottom, which is not how we'll lay it out necessarily, but that's fine. Then we need 5 times 9 for the shelves between each word, and then 40 pixels at 10 words. And our goal is this, 1160. So we can actually go taller, or we can shorten the bookshelf. Maybe a little of both. Oh no, because we also have the vertical depth mark in there. That has to go in there. Okay, and the horizontal depth will be something similar to this, except it's the sine of 120. So it's like 107. Okay. Yeah, the shelf tends to be shorter than it is wide. So we actually have a lot more vertical space to play with. We do want some space around the blocks, so I'm okay with... Oh, we did type that in wrong already. I was gonna say I'm okay with 50 pixels having a buffer around each one. Yeah. Our shelf is going to be short and wide this way. Top and bottom can definitely have more space. 20. We can put more space between each shelf. That still only makes us a square. Okay, what if we change the direction of our isometric grid? What if we make it more vertical? Sine, cosine. Brings that down to 700. That makes that taller. So if we flip our let's see here, where's my yep, here we are. So if we take this grid and we rotate it, let's see here, layer, transform, rotate 90, and we move the active layer. So when we do our isometric depth, instead of going off steeply to the side, we go off steeply vertical and not as far to the side. Oh, new contract hasn't begun yet. Okay. Just been working on some old stuff. Cool, cool. And you were working on your own web page, your own blog and whatnot. How's that coming along? And we can make this 40. Lots of space at the top and bottom. 50 pixels by 10. Now, I have this idea of 40 pixels wide being a decent width for the face of the block. So we have a block. Let's see here. Let's just model out a block here real quick. Plus, minus, plus. How big one this? There we go. Plus. Isometrically, what we're doing okay. Something like there's just no good way to get those to line up, is there? That's fine. I mean, it's not fine. It looks like crap. But the point is, we're going to go up steeper than we are out. But if this is 40 pixels, then the same unit going this way it's basically going to be multiply 40 by sine of 120. And cosine of 120. So if our block is 40 on the horizontal vertical axis, then it'll go up 32 pixels and back 23 pixels. So our total width will be 40, 43, and 30, and 72, 72, 73. 43 by 73, or 63 by 73 for the actual space of the block. So this 40 here doesn't actually work. That needs to be 63. Now we're way too wide. And here, instead of 50 words, it's 73 pixels per word. And that's just about the right height. We're looking for something like this. So the width is the problem. Which I was better at art. All right, let's see. I need. Think about this. I do not want this much height. Want it, or not quite. I don't want this much width. So maybe we shrink things down. Let's go 5 pixels here. That doesn't buy me much, but let's do it. The horizontal depth now. Half a meter deep. We said sine. That's 108. How big are the, each shelf gets 5 pixels, so we could do, yeah, 5 is fine. 20 here. We haven't set anything in stone yet, so I kind of want 2 at 5 and then 1 at like 3. Left, right, vertical, center, vertical. I'd like this to be a little wider. 2 times 10 plus the 5. It's just too wide. Too wide. It's still wider than it is tall. Our letters are too fat. How do we get more letters into our width? All right, I'm going to pause briefly for a restroom break. Let's put this into a thing. Layoutmath.org. We can put things in tables and whatnot in org mode. Bookcase. Letter block. Therefore, the letter block is about that. Bookcase horizontal spacing. We can put these into tables and have it recompute if we want. If I can remember those keyboard shortcuts, but I'm going to take a short restroom break and think about what my problem is here. Just a moment. So I know what I was doing wrong on my math. And I'm starting to think we should not do this in an org mode. We should write a Python script so I can just keep punching in numbers until I get things to balance the way I want. I think that's the right answer. So we're going to be doing a good amount of math letting this out. So let's get a Python script up. Sure, whatever. I don't care about that. We want isometric direction equals tall. ISO tall or ISO wide. Isometric direction. Def. Additional width of a number. Okay, math. If ISO dir is equal to ISO tall, the width is the smaller. Therefore, we can return the value times math dot sine of 120. Otherwise, we just do the same thing but for cosine. Okay. Now def ISO add width, we need an ISO add height. And these are flipped. So actually, we just say if not ISO dir. Okay. Easy peasy. And then def ISO size width height. We're going to have a lot of isometric rectangles that we turn into something else. So we return width plus ISO add width of our width. Our height plus ISO add height of our height. Okay, just building up some little math tools here to reuse. So to test it, we can test it against the block. So we can print modulus D, modulus D becomes those things. So we can say 40 by 40. Just 0.1 F, 2 F, sure. ISO size of 40 by 40. Okay, we can do it this way. That should match what we calculated before. So let's just take this to the shell. Oh yeah, we can't. Not here in a console. We're already running. Actually, we don't need to be running this. We can kill that. Okay. cd dot python layout math.py. More parentheses. Okay. So we went to layoutmath.org. 63 by 73. Yep. Perfect. Okay, so it's computing those correctly. And in theory, if we switch this to wide, we can get it the other way around. Okay. I tend to prefer wide. So that is one thing. What we need are a whole bunch of things. We need a, I don't know if I want a data structure for this at all, to bundle up a bunch of data into one thing. But if we look at our layout board here, you can see we have a left vertical, a right vertical, and a center vertical. Horizontal depth is the amount we add to our. Okay, so let's go. Let's do this. A bookshelf has a bookshelf width 2 meters self dot height equals. Did I say what its height was? 1160 over, I said 371 per meter. So 3.125 meters for our shelf size. So one thing we need is pixels per meter equals 371.0. Why? I don't know, it's pretty arbitrary. Well, I know why. Because in GIMP, when we had sized out what we think the reasonable bookshelf layout would fill. Oh no, it can't be 371. Okay, this gets more interesting. So our bookshelf, let's see, let's stub out what I'm talking about here. Bookshelf has some depth to it. Like this. So the height, the width I'm talking about is this width. When I divided that in half to find roughly a meter, but it wasn't. The space we have on screen is this plus this chunk. So what we really need is our bookshelf is not 2 meters wide, or this is not the pixels per meter. I said that this total width here, so pipe here to here was 762 pixels. So the question is, what's the distance from here to here? It is 762 minus cosine of 120. Let's see here. Equals some number plus some number times cosine of 120. So if we refactor, if we say 762 equals x times 1 plus cosine 120, and x equals 762 divided by 1 plus cosine of 120. Only. I thought we're going to do way more math than most artists are probably going to end up doing, because I am terrible. Terrible. So let's just make this into a thing. Oops. $420 pixels, half of which is 210 pixels. I'm okay with 210 pixels. So in the case that we have 192, 1920 divided by 210, that's a 9-meter window, and it's 1440 by 210, 7 meters tall. Well, it's field of view, so it doesn't really matter. Okay. Okay, so we're gonna say pixels per meter is that. We're gonna say the bookshelf is 2 meters wide and 3.5 tall, and our depth will be 0.5 meters. I don't have to think about the world except in terms of meters. That'll make my life easier, I think. Okay. Okay, so we have a bookshelf, and we declare things like shelf height. Just a moment. Okay. All right. Shelf thickness, maybe. Look at a quarter of a meter. That's actually really. Oh, meter. 210 pixels per meter. I want 20 pixels. That's about 125. Well, and half of that's 0625 or so, which is actually 0254, right? That's an inch. It's kind of a thick shelf, but it's okay. So if it's 2/100ths, that's 4 pixels. It's not very much pixels. Melancholy spell is a bot. Lovely. Okay. Alright, so shelf thickness, wall thickness. 0625. 1 inch on screen. If we're at 210 pixels per meter. Meters 30 some inches. Like 0254 times 210. Okay, so that's like 5 pixels. That's okay. That's 5 pixels. Hmm. Okay, those are all configurable. Self dot characters wide. We need room for 14 characters across. Per column. It's 7. Word columns is 2. Word rows is 10. What we want to do is get these numbers somewhat close to our targets. I think a block. Letter block. Width will be. Oh, I said it was 40 pixels, right? So divide 40 by 210. What? That is the. Okay, fine. I'll put it on its own line. Play that way. So 0.2 meters. Okay. So a letter block. as a size. Which is our width times pixels per meter. We're going to type this a lot. Let's shorten it. ppm. Our height is the same because we're putting both of those perpendicular to the screen. So it's self.depth. ISO add width. ISO add height. Given those numbers. So we get the face width, face height, and then the amount that we add. And the last thing we do is, not the last thing. So dot spacing equals, oh, we should probably indicate our units if I'm going to mix them. Okay. Num blocks equals 1. Ah, there we go. That's basically it. Okay. So we should be able to print out the letter block size. And it should be close to what we computed before. The reason we have this num blocks is because a character wide column is 7 blocks. So here's what my problem was. If we go back to why we were coming up with so much width. When we lay out a block, it takes up this much room. But when we lay out 2 blocks, what we actually get is a little bit different. Basically get this. And that thing is a vertical. That's a diagonal. Okay. So in other words, this extra width here is only added once at the end of a sequence of blocks. So I was adding it once per block. So what we were actually going to get was something more like, oops, let's see. // dash 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 / plus vertical plus minus vertical plus, and there. You can see it takes up more width because instead of overlapping the blocks, we actually drew out both blocks. So that's why we were getting all that extra width. So when we say size, we just take the width that we compute times the number of blocks, and then we only add the width for isometric view once to get that part that's extruding into the screen. let's just try this out. Let's just do letter block.print. That should be very similar to what we had before. It doesn't? Oh, width M, that's true. We did change it. M. Oh, come on. M. It's, this is also M. Come on. Next, there we go. M. Okay. One other thing we want to do is add some pixel spacing between each block. So you can kind of see the edges of the blocks separated by a little bit of color. We'll start with 2 pixels. Roughly like that. Boom. So the width times number of blocks plus the spaces between the blocks plus the amount that we have to add for the isometric depth. Boom, done. Okay. There we go. 42 by 42. That's... Oh. Value times ppm. Okay, 66 and 76. We had 63, 70. So our width and our height, it is taller than it is wide right now, so that's fine. So if we do our size of 5 blocks laid out next to each other, 242 whatever, 7620. Okay. I like the way this is looking better already. So 7 per column is the thing we need to do there. 330 pixels per column. And I said that the halfway mark is 371 pixels is about the halfway mark of what we've got. So that is enough room. Whew, okay. So I think we're slowly getting there. Okay. Bookshelf has a size as well. All right, we're going to return 2 numbers. And what we want is our width plus 1 shelf thickness plus self dot wall thickness times 2. That's basically the width. Plus ISO add width of self dot depth. Okay, we need to change all these to be consistent. Underscore meters. Oh, what? Meters. Height. Times 2 wall thicknesses, one at the top, one at the bottom. But shelf thickness is a lot more of them. Times 9 shelves. Self dot shelf count equals word rows minus 1. Okay. Bookshelf, shelf. Given a block. So if we change the size of the block, it's passed in. Then shelf dot size. I think this is the pattern we want to use. Block dot width. Block dot height. Block dot depth. Okay. With shelf one. Yeah. Okay. So that's just given the outer dimensions that we stated. Word rows. Okay, fair enough. That is also fair. Don't need this number here. Yes, yes. I was debugging a thing yesterday and this morning, and it's amazing what a difference being able to run my editor at full like screen size, what a difference that makes. Like when I'm streaming, I'm so constrained on like column count and height. It's actually harder, I think, to. Oh, what did I change it to screen view? How did I do that? Like there's so much more room for me to like look at different things in different columns and not way more efficient. This whole streaming thing is a little bit not crippling, but kind of crippling. There we go. Okay. So if we set the shelf size as 2 meters by 3, 2 meters by 3 meters by 0. Oops. Yeah. I need to give shelf a bit more. Give it 2 decimals. Okay. 481 by 7 something, which is nowhere near the height we calculated, or the width. We calculated it at 742 by 1160. But we did change our width and our height because of the pixels per meter. Okay, well, we can do something about that. So 481. And we said that it probably should be 742 wide. So dividing 2 by this amount, this should be 3 meters wide. And we said it should be 1160. 618. Not sure that straight ratios are going to do it, but 3.125 we said. So it's 5 meters tall all of a sudden. As long as we're consistent, it doesn't really matter what the numbers are. As long as the scale is about right. $691 by $1121. Yeah, that's not quite correct. It does not scale linearly. So we need to do math again. Oh, the math. Math. There's probably a more artistic way of getting this, but that's not how I roll. Okay, well, all right, let's do the math. What we're going to do, we're going to say that 742 equals some number plus some number times, and this is the width, so it's the lesser, so it's sine of 120. We refactor 742 equals x times 1 plus sine 120. Therefore, x equals 742 divided by plus 1 of sine 120. Really? It's going to do this to me? Oh. Fine. So the width is that. ppm. Yes, thank you. Okay, fine. 210. Sheesh. Okay. So it's 2¼ meters wide. Is that right? And if my height is 5.05 cosine 5.05, and x is 5.05 divided by, not used to prefix notation very often, 1.0 of cosine 120. Of course. Divide. Oh no, that's the wrong number. I don't want 505. 5.05. We want 1160. Like this thing by 210. 3.05. Huh. Neither of those is the number I computed. Width by height. Not even a little bit. Working on layout and visuals today. Yep, we're doing it with math as opposed to art. I am more of a math person, I'm afraid. So I'm just trying to figure out, like, basically where to set the guidelines up in GIMP that are mathematically correct for the isometric projection. Time for new gum. So basically I can set the parameters for a bookshelf and say, well, I want, this many pixels, or I can set this many meters on this axis, and then it'll tell me how wide and tall it is. Then I can go look at what I've got already in GIMP and say, am I within this range? And if so, like, am I close? Could I afford to make walls thicker or more space between letters? That sort of thing. Which, as I said before, is probably the wrong way to do it, but, I want 742, 1160. If I have 1160 pixels equals a width plus the amount that we have to add on for the isometric addition. And this is the vertical component. So actually this could be y. Let's change this to y. So therefore, drop the y. And we take 1160 divided by 1 plus cosine of 120. And it's that many pixels divide So that is not our new height at all. Is it? So then we take this height, so this is y. Oh.
Daddy?
Just a moment. Okay. My goodness. So anyways, I'm trying to parameterize the whole system. So if it's 639, does it really add that much to the height? That's it. And 60 by a number that's bigger than that. It's a smaller number. Cosine of 120. 0.8. Oh, is this in? Oh, this is in degrees. So if you want it in radians, which is what we need, it is divided by 180. Okay. Times pi. 0.14159.265.358.979.323. Good enough. Now, everything that said 120 before should say ISO angle. Which of course we don't have. Because why would you divide that by that? Cosine plus 1. Okay. That doesn't feel quite right either, at all. 11 meters tall. See, these numbers are nonsense. I think it's nonsense. So what am I doing wrong in my math? 2 pi. One eighty, 183. So yeah, two radians. No, not 2 radians. All right. Math while streaming, never good. Deg 2 rad. It's gotta be just a number. Degrees times pi over 180. Yeah. This is mathematically the same. Pi over 180. 120. Minus 1/2. Oh, that's the cosine. Yeah, so the radians is still the same. Cosine of that 120 would be negative 0.5. That's fine. Add 1, make it 5. Somehow we're at 11 meters. Because we divide by pixels per meter. Guess we can throw it in there. 0.05. The width would go through a similar song and dance of 762. X plus x times cosine 120. 762 equals x times 1 plus cosine 120. 762. This mass, except we use sine. And it says it's 2 meters wide. That's just absurd. Plus 1 sine. So there's my radians. 2.866 sine. So this one goes to sine and cosine. I think we're laying out the other direction. I don't know. These numbers are not coming out the way I would expect. What am I doing wrong here? It'd be nice if I could just drag guidelines to the mathematically correct place and draw them from line to line. Not because it's going to make beautiful art, because then we can do layout. If it's just semi-ugly, at least we know that we're not going to change the spacing. We can use the ugly art as a guideline for the better art. It's the other way. So block size. Let's make everything 3 decimals here. In meters. Okay. So our block is 0.2 meters. Yeah, that's way off. Close. Okay. Oh, of course. Times 180. Oh, never mind. We can do the angle this way. Yeah, whoa. Whoa. That is a little bit on the outrageous side. So if we're drawing a line, so here's the question, right? Let's if we have our block. I'll just get a block here. Oops. The question is, for the width of this line and the height of this line, which it's 120 degrees, angle. Oh, let's see. So it's actually 60 degrees. 120, 60. .30 would be the more horizontal. 360. $120 is a slightly different angle that we're talking about. It's 20. And it's rotated by um, yeah, these are not correct numbers at all. Oh, just a quick sketch. Reveal the faulty thinking. The ISO direction no longer matters. We compute that at the angle time. Now if we're at 90, well, if we're at angle 0, 30, 60. 30 is the wide one. The tall one is 60. Okay, maybe we path dot beg to rad. I'm pretty sure that's a thing. Writing width. That's 30. That'd be cosine. That'll be sine. This is called. Come on, Python. Yeah, 2 rad. I thought it did something like this once. Oh, okay. Python beg to rad. Pretty sure it was a constant. Should make an actual. Make the call. Okay. Fine. Okay, those numbers are still completely out of whack. Oh, that's 7 blocks. So let's go back to 1 blocks. Okay, 63 by 78. 63, 73. Probably this is the better answer anyways. Okay, so width used to be 760. 762-ish. Right, so 7062 is our mystery width. And this is our horizontal, so it is sine 30. Right, so sine of 30 width. With this cosine, we're going up 60 pixels. Isometric is tall, so it is 60 degrees. Okay. .508. 2.4 meters wide. Yes, thank you. And the shelf width is not correct. I want 762, so why isn't it giving it to me? We take the width of our shelf times, to scale it to screen space, fine. Plus 2 times the thickness of the walls, plus the wall thickness. Okay. So here's a couple of smallish things. $588. Plus the ISO width and ISO height. That's worse. 3 and 5. Let's try it. That's closer to anything else we've got so far. 4.5. Seven five. Let's say 1160. Okay, that is plenty close. So 924. .5. 819. 766. That is awfully close. Okay. Although It's not quite right. This stuff is only added when we're computing it with all of our other nonsense. Something. Okay, that's close. 787 is too big. 1140 is getting close to right. 777 is close. 1146. Where's a good binary search for it? More or less. Okay. 75. 8. 4. 1157. 8. Oh, interesting. 59. 60, almost 1. That's really close to 62. Okay. So in theory, that's our bookshelf dimensions. Throw away all the math. So what we want to check is computed height, computed width from the parameters of the shells. So this is characters wide per column. Block dot size of the number of characters per column. Okay. This goes in width. So we have 7 characters per column plus meter times the wall thickness times 2. Plus shelf thickness. So we have a wall, 7 characters, a thin divider, another 7 characters, and then another wall. So we have 2 columns. Oops. Self.word columns times that. How many columns? That many blocks in a character wide. Plus the ISO add width in meters. Computed height will be very similar. Return word rows times block. Oops. Block dot size 0. Block dot size so 1 because this is a height. Number of rows times the height of our blocks. Plus shelf count times ppm times self dot shelf thickness in meters plus 2 times pixels per meter times self dot wall thickness. How much at the top and bottom? Okay. Okay, so our computed width is actually very close to correct, and in fact, given our block size, that's not bad. We have 9, 10, 11, 300 pixels vertically to play with? Really? Well, let me think about that. If I have 10 of these stacked on top of each other, that's almost 800 plus a bit of spacing here and there. That is a thing we need to have. Although, not really. This is still considerably shorter than we have to have it. 780 to 856 to 30. So we have some spacing around each block, each shelf spacing. In pixels equals, I guess 10. So when we compute a height around these, self dot shelf spacing pixels times self dot word rows. So yeah, we can have 5 pixels above and below. We don't need that much, so we need like 5 per. Honestly, 10 is fine. Is 10 fine? 25% above. Okay. 5 or 10 pixels. I want really 10 pixels above each block. We can make the actually wall thickness. Bottom top thickness can be quite a bit more. 0.25, a quarter of a meter, split between 2 things. Oh, which that's fine. So when we're doing the computing the height, we don't use this wall thickness. We use the bottom top thickness. Okay, that's getting us closer. We're 160, 170 pixels short. Even with all that extra vertical. How much? 730. That means we can have a good amount of spacing for both columns. That's fine. So we could add a horizontal word spacing of that difference. So 12 pixels. Oh, we're rename that word spacing in pixels. Horizon. Let's see, V spacing. Horizontal spacing is 12. Let's make that 12 as well. Word V spacing pixels. Plus 2, or let's see, number of columns, self dot. Word columns and self dot word horizontal spacing. Oh. Oops. Shelf count, self underscore shelf thickness. There we go. Okay. So the heights I'm pretty happy with. Or the widths. Widths I'm very happy with. Plenty of room for spacing and playing around with that. This one, 161 pixels short seems a bit much. But I don't really mind it that much. We can lower everything by that much. What's the ratio of these two? It's not the golden ratio at all, but it is actually pretty close to 4 to 3. That's not the worst thing ever. So let's make a bottom thickness and a top thickness. And we'll make it 1875, 1875. This one is minus 0.25 minus 0.1875. There we go. It's just a 16th. Okay. Why don't we do it that way? Top thickness and bottom thickness. Okay. I don't mind it being a little bit short. That's okay. 12 pixels above, some amount below. Okay. So, what we really want to do now is simulate the layout. Travis, thanks for coming in. See you tomorrow. Hopefully, we'll have some grid lines in GIMP that are our final layout for some of this stuff. So, thanks again. Thanks again. Okay. Simulate the layout. Self. Margin X, margin Y. Works my hard to put those at 20 for now, because I think that's what it is in our layout. And what the point of this is, oh, and our height equals 1440, width equals 1920. Okay, let's see here. X equals margin of X. Right. 0.3F and a description. Shelf starts. That will be an X. Then X plus equals self dot wall thickness in meters times ppm. Let's see here. Column 1 starts. Then we add word horizontal spacing. That is letter words. 1 starts. Then we want self dot block dot size given self dot word characters wide per column. Word 1 ends. So basically we're going to be able to look at each grid line, know the number and what it means. And we're add another one of these spacing things. That is column 1 ends. It's the same thing as middle vertical divider begins. Okay. X plus equals self dot. Now it's not wall thickness, it's, we're going to use a shelf thickness. This is I think what we decided, right? We're computing width, shelf thickness. Yeah. Middle vertical divider ends and column 2 starts. Shelf starts and wall 1 starts. Wall 1 ends and column 1 starts. There's a spacing to the words number 1 starts, words number 1 ends. Column 1 ends and vertical begins. Middle vertical divider ends and column 2 starts. Okay. Then honestly, word 2 starts and ends. Words number 2 begins and ends. Then column 2 ends and wall 2 begins. Okay. x equals this thing. We add the wall thickness. And then column, let's see here, wall 2 ends and the shelf ends. So in theory, this is all the x-axis information we need to lay things out for the whole scene. Took us a while to get here, but I think we're gonna try it. And hopefully the width that we computed is the same as what we had before. Shelf dot simulate layout. Plus equals things. Block dot size. Oh yeah. I guess that makes sense. Here we go. So at 20 pixels, this happens. Wall 1 ends and things begin. Okay. And at 753, which is not the same thing as 762, so what did I miss? We're missing 9-ish pixels. This number here should be very close to this number. Very, very close. Oh. Then we add the depth. X plus equals add to width. ISO add width. Depth. Isometric expanse begins. Isometric expanse ends. And that's definitely not right. 806 is not 762. Huh. So we compute our width. We're adding the characters wide per column twice, which is the number of word columns times the block size of that. Oh, math. Okay, so I believe this is properly represented in this. Okay, we do have the spacing, the margin. That should be only a 20 pixel difference, not 762 from here is 38 plus 6. It's 44 pixels off instead of 20 pixels off. So we're picking up an extra 24 pixels somewhere. Okay. Wall thickness times 2 plus 1 shelf thickness. So here's a wall thickness, and a shelf thickness. Let's mark these off. We've got a wall thickness and a wall thickness and a shelf thickness. So those three match 1, 2, and 3, and they're all multiplied by ppm. Yes. This one is added in twice, just like up here. So let's mark those out. We have 4 word H spacings. Oh. Divided by 2. We're only taking half the spacing before and half the spacing after. That could be the issue. Okay, 782, which is 762 plus our margin. Boom. Okay, so that's all of our X coordinates for everything that happens across the length of the bookshelf. Finally, let's get our Y coordinates. We're going to start at the bottom of the bookshelf. So Y equals our height minus margin of Y. See, this way, if I decide to rescale or tweak a width or a height or something somewhere, I can always relay out the whole grid without too much trouble, I think. Okay. Let's be Y. So, shelf begins and bottom of shelf begins. Okay. I'm going to add the bottom thickness. Y plus equals self dot bottom thickness ppm bottom of shelf ends and row 1 begins. Okay, so from there we had a block height. So let's see, let's take this. So we have the y plus equals, oh, this is all minus equals, so we're moving up the screen, thank you. Minus equals self dot block dot size, and the size does not matter in terms of that number of blocks, because we're just taking the first slice. Top of word row 1. Minus equals self dot word vertical spacing in pixels. Spacing and bottom of shelf 1. Then we add the shelf spacing. Oh, no, we don't. So what we're going to do is we're going to say word count in range 8, not 9. Y minus equals self dot shelf thickness times ppm. Top of shelf thing and bottom of word row thing begins. So this is count plus 2, count plus 3. Let's just see what that looks like. Okay, so y, top of word 1 spacing. Okay, so blah, 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 blah. Start x equals x. Start y equals y. Total height 0.3f modulus y minus start y. Let's make it easy on ourselves, right? To understand what's going on. Width equals x minus start x. Okay, total height is some number. Yeah, none of this is done, but that's fine. Because this total width matches very well with this width. Okay, let's go finish up some more of this stuff. We can net these 1, 2. No. 2, am I getting the numbers right? We hit shelf 10. We didn't want to go to shelf 10. We want to go to one less than that. So there's 8 shelves, and we're going to do the first word row without a shelf. Okay, so we do that, we do that. Okay. So we get the bottom of the word. And then we get the top of word, and we add some spacing. Okay. So the top of word row plus 3. Count plus 3. Count plus 3. All right, let's run that. So we're going to go up, up, up. This number is not yet complete, but we also have to add top thickness, top of shelf ends. Okay. These two need to be reversed. Because we're going up from bottom. 920. Okay, so I'm missing some things. But we are getting our layout just about hammered in here. Compute that it's this tall. Some things we can do to improve it would be to use more integer values. So for example here, the 1/8, I'm not worried about the 1/8. These ones at 0.5, those kind of annoy me, but it's not that bad since it's the middle vertical divider. Yeah, that's all off by just a tiny bit, just that 1/2. So maybe we need to get rid of this pixels per meter nonsense. Yeah, we might have to. Okay, but anyways, so what have I forgotten? The shelf begins, bottom of the shelf. Bottom of the shelf ends, and we're into word 1. We go up the height of a word. Then we add a spacing to it, which was 20. My gosh. Was it 20? I don't think so. Word V spacing. I swear it was like 12. Top of spacing. Oh, that is 12. Okay, yep. Bottom of word row 3, all the way up to word row 10. Oh. Let me go up the height of the shelf. 921. Somewhere I'm missing a thing. Or we've miscalculated something. So we have word, let's see here. Word rows times block size times 1. There are 10 of those. So I need to see top of word row. Let's see here. V spacing plus block size plus shelf count, which is less. Thickness, bottom, and the top. There's our bottom thickness, there's our top thickness. Let's mark them out. Word space. Word space. Word row 1. Shelf 1. Top of shelf. Oh. 1. 2. 2. 2. 2. Okay, so I think this actually goes for 9. Instead of plus 2 and plus 3, it's plus 1 and plus 2. I think that'll make more sense. This is not the top of word row 11, it's basically the top of nothing. The total height is shelf begins and the bottom of the shelf begins. This is the bottom of shelf ends and top of word row 1 begins. Top of word row 1 spacing. Top of word row 1 begins. Word row 1 ends. And bottom of shelf 1 begins. That's wording 8. So, top of shelf thing and word row 2 begins. Word row thing ends. And shelf 1 begins. There you go. Top of shelf. So shelf thing ends. Word thing begins. No. Okay. Bottom of shelf ends and word 1 begins. Word 1 ends and word 1 spacing begins. Word 1 spacing ends and shelf 1 begins. Okay. Shelf 1 ends and word 1 begins. We move up the size. So word thing ends and word thing spacing begins. Word thing spacing ends and shelf thing begins. 1, 2. So think. So it's okay. All right, let's try that. 1117, which is what we computed. Good. Okay, so it's just us not quite keeping track of everything correctly, but this is it. This is our full layout. All we need are all these grid lines, and we're done. Isn't that simple? Phew. All right. So the question becomes, we turn this into something actionable. We want to, this is for us to be able to check. But this doesn't, this is in, we have, we're going to create an image. And we're going to exactly lay out this stuff. Let's make everything integers. ppm 210. So anywhere that this happens, we're going to compute it real quick. Oh, for Pete's sake. So 42. 42 by 42 by 42. Those will all be changed to pixels in a bit. So let's see here. We're going to remove ppm. Those are pre-scaled. All right, this one. $7.10. $10.71. And 105. We're just replacing everything with integers. Oof. Oops. Actually, yeah, actual integers. Oof. 5.3 shelf thickness. We have height to play with. Let's make it 10. Let's go crazy. $13. 7. We did very, very carefully calculate this, didn't we? Let's make this, what did I say, 025? 3.0254. Made it 5.5. If we have that, so 2.5 pixels thick. Okay. Just trying to think through our layout. Eventually, we're gonna be putting things in the scene very mathematically. Okay. $39. So we can go to 40, and I'm not going to feel too bad about that. $26. I'm okay with 25. Spacings. Okay. I think it says ppm goes away. I think it was a useful starting point. These are all going to be changed to underscore px in a second. Okay, then calculate the y. The top of shelf ends, but we need to add this thing. And oh yeah. And isometric expanse begins. Isometric expanse ends. Now this is height. Okay. Phew. So our total height now is less than it was. Why is that? These numbers almost all come in beautifully except for this one, which is fine. I don't mind fudging a half centimeter there. Oh, blocks. 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 Blocks need to change. Okay, first thing we're going to do is we're going to change all the underscore m's, underscore pixels, so everybody knows what units we're in. Okay. 20, we come up some amount of pixels. Where one ends, so this is where all the rounding is going to actually have to happen, which is a little bit unfortunate. The block size is 63. Do we just force it to 78? Make that an integer number. We could. And this height, does it match this one? It does not. So again, we have a mismatch somewhere. PPM is not in here anymore. So where we do the block thing. Everything's on a pixel. Our total height. So the shelf begins, the bottom of the shelf ends. Word one, shelf, etc. 5, 6, 7, 8, 9, 10. Word 10. And shelf 10 is actually top of the shelf. And then we begin the isometric expanse, which is like 90 pixels. Holy smokes. But the blocks will be sitting on top of that, so it's not like it's actually empty dead space. So what did I forget then? But the width, 761, is correct for what we computed. Yeah. 10, 10. So somewhere I lost 100 pixels. Where did I lose 100? Oh, no. Yeah. I lost 100 pixels. 100 pixels. I mean, I can easily put things on the shelf. Like the banner. The banner could be at the top of the shelf. It would be smaller text, but it could work. I lost 100 pixels somewhere. There's a lot of pixels to lose all in one place. Where did they go? Huh. Simulating the layout should be the same thing as the mathematical equations. That's why we did it both ways, so we could double check our work. And it was matching briefly. So what did I do? What did I do? We added. That's what we did. Y plus equals because we copy pasted that from the other thing. Boom. Total height 1100, which is more than we computed, probably because we did something stupid, but it's close to what we want actually. Why do they mismatch now? That's a different mismatch. That is not the kind of mismatch I like. Okay. So here when we compute the height, we have the word spacing times the number of rows. So every time we add that, and 9 shelves, that's the rows. So that is our let's put this here. Let's put this here. Okay, so we have the number of rows times the size of our letters, the number of rows times our vertical spacing. Then we have 9 shelf count times the shelf thickness. Okay. Oh, I see. ISO add height self dot depth in pixels. I don't know where that went. I thought we had it once. Oh, commented out things while we were verifying what was present and what was not. Okay, now 1100, 1100, and that's close enough to this that I'm fine with it. We could make the top of the shelf thicker than the bottom of the shelf. The bottom thickness is 40 pixels. The top thickness is 25 pixels. So we can add 50 to this. We can make the top thick and use that to hold the banner. The width of the whole thing is only 700 pixels, but right now our messages are too big for that. So maybe that's not right. $1,100. Matches 1100 and it's under the height we want. What's this ratio? We've changed some things. Okay, fine. Huh. 1.4, that's closer to the golden ratio. Okay. I mean, you don't necessarily want the golden ratio, but right. am leaning towards making the top of the shelf. I don't know. Okay, so that should lay out the bookshelf and give me enough information to lay out the blocks. Oof! Just made one of the best stir fries I've had in a while. Ooh, what was in it? I like a good stir fry. Cashews, chicken, sweet peas. Did you do like a teriyaki or what were you doing? What were you doing? I like stir fry. Okay, so now math pie. We're going to simulate the letter block. We have simulate the layout of itself. Okay, one thing we're going to do for this simulate layout. World scene coordinates. Local image coordinates. So when we're laying this actually out, we do want margins of 0. Our width doesn't really matter, but it can be our default width, 720. And our height should be whatever we compute it to be. Actually, we should compute that height. Oops. Pass. Oops. 179. So now it's laying everything out relative to its own height. So when I go to make the image, these are the coordinates I'll use because it starts at 0, 0. Top left corner. Okay. So that's good. Going to block. Where's our block? This thing has a pretty simple layout. Self.size, sum1. Now that I've got X and Y sorted out, I do want to print the X first, then the Y. Okay. This doesn't really need these offsets as much because the blocks are expected to move all over, so I can't really put them in a screen space. All right, so what do we got? Broccoli, breaded chicken, homemade pineapple sauce, nice. Toasted the rice beforehand in avocado oil. That does sound pretty good. I could go for some of that right now. Ooh, nice. Nice, nice, nice. Okay. So, block begins. Then x plus equals self dot height in pixels. Block ends and isometric expanse begins.
Dad.
Just a second. Eesh. Don't think my kids are always they don't always think through their questions, I should say. It's probably the more diplomatic way to put it. Okay. So these are y minus equals. Okay, so let's see. Let's just go through this. X, we started somewhere, which is actually going to be 0. The block begins at the bottom of the image. We go up its height, that's the top of the block. Then we go up the height that we need for the isometric. Actually, this is left to right. So block begins, block ends, isometric thing, and we're done. This one, block begins at the bottom. It goes up the height, then it goes up the isometric height, and then we're done. Block layout. We'll indent everything a bit more. Okay, then the shelf layout. Search for quote, in 2 spaces, go to the end of the line, center. Do that down here, and done. Block dot simulate layout. All right, let's see how this works. So the block should have normal same numbers, 0, 42, 63. We did compute that, yes. Then we start at 78, 63, essentially 0, so that's fine. Total height, 78 can change, that's fine. Good. Okay, so there's the block layout, X and Y. Shelf. Layout 761 looks normal. 1193. So that's it. We have everything we need to start laying this stuff out, except I want to draw the images larger than on screen. But no, this is just our layout. But we're going to use our layout as our template. We're going to scan it in, so maybe it doesn't matter. Okay, well, let's go lay this out. Let's do the block. Block is easy, right? Blocks are easy. So I'm going to go over to GIMP. Save what we've got here. The blocks on top don't matter. Let's just lay out the bookshelf. So I'm going to make a new. Oh, so I guess I need to share the old screen so that GIMP is visible. Here we go. Okay, we're going to make the image size exactly the size of the shelf. So 762. Oops. 762. Right, we're only off by half. So I can afford to go out one more. And 11. Oh, 1. Okay. I guess it's 1101. This is not a power of 2 texture, so that's unfortunate. We may come back around to that. We can power of 2 things up in a bit. Let's see here, 1024, 2046. If we double all of these, that's 14, 15, and 2. That's a big texture. All right, so 10, 24, and 2048. Those are powers of 2. I hate it. It does that. I really wish transparency was just the thing. Okay. So here's our bookshelf. We're gonna zoom way in and start laying out our bookshelf X coordinates. So there's 0, we need 13, 13. So that's the end of the wall. Word 1 begins on 19. That's our spacing taken into account. Is it? Okay, well, 346 is where the word ends. 3. 346. 352. It's the end of the column, so 352. 357, the middle divider ends 357. 363 is where word 2 begins. 363. .690 word 2 ends. .690. 696. 709. This wall 2 begins. Oh, then the isometric at 761. 2. That is our shelf layout on the x-axis. What is this? What does Kim think it's doing? I think that's a valid question. Okay, then we're laying everything up from the top. So 1101. It's way down here. 11 oh no, it's not. Let's get rid of this one. 1101 is right over here. All right, 1101. That's the bottom of the shelf. 11. Everything's off by a tiny bit. 1061. 983. 983. 971. 965. 888. 888. 876. 71. 71. 793. 793. 781. 776. 698. 686. 681. 603. We knew this one would take a while. I don't remember the number. 603. Okay. $591. Oops. 586. 507. 508. Yeah, 508 around 496. 496. 491. 413. 'This will all make sense when we start throwing colors in. Might be possible to script all the guides and give Python foo. That is true. It might have been easier than what I'm doing. if we go through a secondary layout phase, like that's definitely on the table. 100% copy paste these values and just let it lay it out for me. 401, which I had 401. Yeah, only if I have to relay this out. I'm 396. Which I'm really hoping I don't have to do. All right, we're getting there. 318. Go 6. 301. 223. 211. 206. 128. 116. 91. And 0. Boom, there's our bookshelf. Oof, okay. All new bookshelf. Okay. Whew. Now, we left room for the isometric expanse. So I think zero. There's the wall, there's the spacing wall. What's at 709 on the X? Wall 2 ends. So here at 709 is where the stuff we do actually ends. Okay. All right, so let's do this. New layer. Front face. Bucket. Fill selection. Yes. Wrong. Undo. We'll make this some sort of brown or something. Okay. Okay. Then create a new layer. And we will call it shelves, I guess. I don't know. And we need to take into account the spacings around the text. I think that's it. Bucket. Black. Okay. Okay. Yep. I think this is what we're looking for. What my goal is to get these all laid out so that when we lay out our text, we can put it within this inner dotted blue line. We can center the letters vertically, but they need to be left aligned. But then, in theory, our letters will end up laying out exactly from this edge to this edge anyways. That's the goal. Let's see what we actually get. Just because we did math doesn't mean it's all correct. Okay. Yeah, not all of the layout we did was for visual elements, but rather just for spacing and alignment. Okay. Do copy, paste to new layer, and move right there. In theory, that's everything we need. Merge down. Where's my merge? Merge down. There we go. So there we go. Now these should obviously be filled in with some kind of isometric thing, but we're not going to do that right now. Okay. So we need a line. We need to create a polygon from this point to this point. Oh, interesting. Okay, there's 2 points we did not actually compute. That might be handy. That whole power of 2 requirement sure does waste a lot of space. We can pack more stuff into this texture. Hey, Toby1364, nice number. What are we making? We're making a game with no game engine. We have just yesterday completed all technical programming problems. So we are in the, instead of crappy developer art, we're going to make mediocre developer art, which means we're mathematically figuring out all of our layout. We're going to make bad art, dump it in the game, and align everything so that the animations can start being polished and all of that. Then we can use that layout to draw better art. Even though I'm not an artist, it can't be worse than what we've got. So that's where we're at. We're in art mode today. I'm laying out the physical bookshelf the way that we want. As soon as I get this image done, we will export it and import it into our asset pipeline for our engineless game, and we'll see how it looks. Welcome, welcome. If you have any questions, let me know. I'm happy to show the game as is, or talk tech, or I'm not really willing to talk art. I don't do art. This is it's not what I do. But when you're a one-man game dev, you do what's got to be done. So this rectangle is very important. This is the angle of our isometric extrusion, right? So let me math just a teeny bit, because that tells me the width of the extrusion. So we're at 709 and 762. 5, 12, 3, 5. So it's 53 pixels wide. And height-wise, it's from 0 to this line, which is 90. 53 by 90. That's our extrusion. So if we go over to this corner, we're going to need a thing at 53 pixels to guide us. Okay, so this is our, we need a top polygon from corner to corner, from this corner to this corner. We'll make that one color. So yeah, Toby, welcome aboard. If you are interested in what we're doing, I do have a Discord server where you can get notifications when I go online. We will be doing art polish work over the next several weeks while I go through the business stuff, Steam onboarding, integration with Steam, all that stuff. So we've got a few weeks left before the game can possibly release. Very small game, narrow in scope, so that we don't get bogged down in grandiose plans. We're trying to crank this out before the end of the year and have it on sale. Then the second game, we'll use the code we've already written to springboard ourselves into something a little bit bigger, but not too much. This will be like more of a polish, like a refinement phase. Like I have a list of stuff in a text document that I want to fix in my code or improve in my code. And after we've got about 2 games done, again, simple, narrow scope, then we'll crank out something new, interesting, innovative, more ambitious. So yeah, hopefully we'll follow along. All that jazz. Okay, so where was I? Select. There's an ellipse tool and a rectangle tool. I would like to draw a polygon. I don't know how to do that. GIMP. I don't know how to do GIMP things like the basics. That's it. GIMP. Select a polygon by vertex, by vertices. They want me to use Python. Ooh, I've been trying to avoid that. If I could do everything with code. Let's see here. GIMP. Path. Polygon. Paths. Okay, I want a polygonal path. So I use that tool, or B. So I can go B. So in theory, I can go from here to here to here to here, and then how do I close it? Close. How do I close it? When the mouse cursor is close to one of the path points, the plus. I don't want to move. To close your path, go with the mouse on top of the point you want to connect to. Control click. Okay, so I have to control click. I remember this was always a big pain. Now it's closed. Now we should be able to selection from path. Bucket. Now we take this brown, maybe the slider one. New layer, top, extrude, and bucket. Okay. Now we get the path again. Let's get another new layer. side extrude. Okay. So we're going to select from here to, oh, wait. Did the path not snap to those vertices, those points? Oh, good heavens. Okay. Select everything and delete. Cannot believe this. Okay. Path. Design, edit, move, polygonal. Do I just have to be zoomed in that much to make this? If I want, this is the whole point of these guides, is like my mouse should just naturally go to it. So why did it not snap to those guides better? Maybe if I had a more up-to-date GIMP. Maybe. Click. And now control click. Wait, what? What is that? Ah, for Pete's sake. All right. We will figure this out. Okay, point. Getting dizzy looking at all these checkerboards. Click. Oh, now it's snapping to. Of course. Why wouldn't it? Snap to. Sheesh. Okay. Click. Now we. Oh, what? No. Undo. Go to this point. Come over here. Not that. Snap to grid. Good. Snap to grid. It can, but only during edit, I guess. And then we control click to join and close. Select from path. This is the top extrude, so the bucket as before. Go to side extrude, unselect everything. We get our path tool back. Okay, down. Oh, we said it was 90 pixels high, so this is at 730. Oh no, it's at 1101. 1101 minus 90. 0, 10, 1. Oh. So 10, 11. We need a guide at 10, 11. Okay. Right there. Now we can draw the polygon. Polygon tool. Drag it there. Drag it there. Oh. There. Then we close it. Selection from path. I want a darker brown for this side. Bucket. Oh. There. That is our mathematically correct, not very artistic bookshelf. By mathematically correct, I mean if you were in an isometric view, this is about what we're looking for. Now, each of these shelves should probably also have some color to them. We're just checking layout right now. So what do we think? Is your Snap 2 guides on under view menu? Yeah, it is. So I guess when you're, maybe I wasn't clicking close enough to the guides. I guess I did put it there. Maybe just going to the guides. Oh, so yeah, you have to be pretty close before it'll snap. But it drags to snaps, so I don't know. I don't know. I don't use these tools enough to be an expert in them or anything. So in theory, this is 90 pixels tall, and the block size we computed was 78 pixels tall, so that'll fit nicely. Those blocks will lay on top of here just fine. And the height from here, XY 206, to here, this is in theory the top of a block. 128. Maybe if I'd write this somewhere else, 206, 128, 110, 8, 9, 16, 8, 78. So yeah, up to here is 78 pixels, so it's exactly the height of what I think we'll want to do with the blocks eventually. Okay. Right, so we're gonna put this somewhere. Active projects, word sleuth, assets, images. So this is the layout of the bookshelf. Okay. Let me see here. Modern GPUs, how important is power up to texture sizes? I know it used to be a thing where it's like, whoa, buddy, the performance really, really cares about power of 2. But I'm not sure if that's true of modern hardware. I'm just not sure. There's room for debate here. What you're using, a lot of popular tools engines like UDK would demand that the texture be a power of 2. Some graphics cards prevent strange size textures from displaying. Okay, so if there's actual some hardware that still cares, some get a particular boost from, but do not require a power of 2. Okay, well. Okay. So yeah, we probably should stick with power of 2. Okay. So in that case, here's our bookshelf, and we have a ton of room to pack other textures in here. Like we can put, so we got the books, like we can have several rows of different kinds of books and randomly pick them. That's always an option. The block textures we can have here, down this row, column. Okay, so let's do this. We're going to export as, we're just going to call it bookshelf. Okay. And now we're switching modes. We're going to go from GIMP mode to Emacs mode. All right, Emacs, here we are. Boom. We need to go to our assets. We are looking for images, not text. Right, we want bookshelf.png. pretty sure it's in here. Bookshelf. Yes. UV rectangle. So like I said, we might pack more in the end, but we're gonna call this one UV rectangle for the bookshelf is at 0, 0, and it's some number wide, which I don't remember. 7 something, 762, and its height way down at the bottom is some number which was 1101. Boom. UV rectangle. And done. So that should be added into our asset pipeline. So let's go to here, file. Just pause there. Quick restroom break, or no, snack run. Snack run. We'll go snack run. I need some jalapeno poppers in my life. I'm getting tired of this gum. Be back in a minute. Okay, in theory, we are back. So what we just did was we said we've got this new image and the pixels from 0, 0, top left corner, down to 762, 1101. Treat that as a UV rectangle. Okay. And now we're going to start playing with new layouts for the game scene with this as the starting point.
You know, right?
Okay. You run that. Embed PNGs. Bookshelf is probably now one of our biggest images. So our program size probably is growing. Okay, so we go to sandbox. Compile. Let's just do a full clean. Why not? Oh, layoutmath.org. What I'm gonna do is get this data off the old shell where we were looking at it up here. Okay, so bookcase shelf size. Computed. Then we have the shelf layout. Clicking on the x-axis. The y-axis. 1, 2, 3, 4, hyphen thing, delete the 4, 2, 2, 2, 2, 2. All right. Okay, so we've got a bunch of data, a bunch of informations. Okay. Letter block. There's some of that data as well. Layout, X and Y. Okay. There we go. So this data is now safe. We rebuilt that thing, sandbox theme. Let's just do a clean and build with our new image in there. Let's start making new layout tests. Now, obviously, we're going to have more coding that we're going to do. So, for example, like you're talking about these blocks, I think what we're going to do is everything on the bookshelf side of things is going to have the letters superimposed over like letter blocks. So we'll have to write code for that sort of thing. Okay, so in the sandbox, we're gonna do a thing. We need a new test. We're done with sprite testing. That function never needed to happen. Oh, and that. There we go. Testing layout. So we're going to have a text quad for the bookshelf. Let's just call it shelf. Then we need init, update, and render. Layout. Okay. Delicious. Okay, sprite. Init layout test. Update layout test. Render layout test. Render. I don't think I have any update, but we'll throw one in because sometimes you just need to do a test with like a space bar or something. Okay. Okay. We have a text quad. We are calling m_shelf. Set the texture, we set the rectangle to something. Now what we have is a margin. So margin equals renderer scale H. And the number we want is, we said 20. We said 20 pixels on the margins. Okay, then the bookshelf height. Renderer scale height to 1101. Shelf width with these static fonts, because why not? Renderer scale width 762. And then we put this at margin, shelf width, shelf height. It's not called quad, it's called _shelf. Asset bookshelf. Update doesn't do anything. M_shelf gets rendered. We're going to call that a decent starting test, I think. So we're done with the layout. We actually know the pixel size of everything we want to show, and that they read okay on the different screen sizes. There's kind of no point in trying to do more art. Okay. Here we go. Oh. We own this. We do not need a pointer to it. Source builds debug. Okay, we go to the sandbox, and that is very cute, but wrong in its size. Doesn't look that bad on screen though. Oh, it was the bottom margin for one. For two, scale height 1101. So now, first of all, we're going to take renderer frame height minus the margin. Shelf width, shelf height. In a 1024, let's see your name. I feel like that's just small. Oops. Oh yeah. Function. I always forget that. We have to have a little bit of control over who does that. Pop with jalapeno poppers. They go way too quick. Okay, sandbox. Now, oh, we did not set the UV correctly. Set UV to image warehouse, UV key bookshelf. Then it will magically work. The way that we'd hoped and dreamed all these years. Boom. Hey, there's a bookshelf. Cool. Super cool. That already looks better. Let's go to Huge Normicus settings and see if it looks comparable. That is not comparable. Huh. That is odd. That should scale up with the window size. Got a seed in there. Teeth here. Oh. On the teeny tiny screen, it's fine. If I go huge, it's not. What if we relaunch it? Oh, static. Static. No. We don't want. There we go. That should fix that issue. Oh, I forgot to spin those that way. Okay. I don't know why I did static. So there's Huge Normicus and teeny tiny. Yeah, that scaled better. Good. Okay. So there's our bookshelf. Let's make maybe one small improvement. See that angle there? I want that same angle here. And this is 70 something pixels. I look. Oh, wait, you're not looking at the image. I need to get better with this whole OBS thing. Oh, let's go back to our layout math.org. Okay. So the block is 78 pixels high and 90. So the spacing between it's 78 plus some spacing is 1280, 80 pixels. Yeah, so we can draw the shelf all the way to the back. So this angle here, we want to put here and put this light color underneath and the dark color on this corner. I think that'll give it a lot more depth instead of looking flat. Let's try that. So this is, I forget, 13 pixels for the wall width. And we said that the width was 53. 53 plus 13 is 66. So if we come over to 66, if we come up from this thing 90 pixels, that's 205 was the top of the last shelf. Shelf layout. Word 10 begins. Yeah, end of shelf 9. Correct. Oh, and I'm not showing GIMP. Where's GIMP? I'm the worst. Okay.
Someone else can run it now.
So we've got this guide marker here, and we need this thing 205 minus 90. 205 minus 90. 110, 1. Oh, no. 115. No, just 15. 15. 115. There we go. So we need the guide at 115. Oof, that's close. Okay. But now we can use our polygon tool, which we've learned all about, to go from this corner here to this corner here. New layer, new layer. Shelf extrude. This is what we're gonna shelf extrude bottom. So that's from there to here, here, and there. There we go. Image. Select from path. Bucket using our light tone. Okay, okay. Then get our path tool back. We're gonna go from this corner to this corner to that corner and close it. I want the dark color. Bucket. Oh no! I ruined my path. Okay. Click. 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 Select from path. Bucket. Fill. New layer. Shelf extrude side. Now bucket. Okay. Now we merge these down. And clip out this top pixel. We don't need this top pixel. Delete. Okay. Let's see here. Layer crop to content. Paste to new layer, move it right there. Okay. So I think that adds some depth. We may have to put in black outlines in our final art just to show things. Okay, so we merge down, duplicate, move, there, merge down. Now we've got 4, duplicate, move, okay. All right. Merge down. Duplicate. Move. Boom. Right there. I suppose we could have done things a little differently. That's fine. Merge down. Box select. I'm gonna go for the bottom two. Oh, that's not a box select. This is box select. There we go. I'm gonna grab up these two. Copy, paste, move. Right there. To new layer. And assuming all looks well, we can merge down. There. Save. Export to bookshelf. Okay, now we go back to our code. So we hide GIMP. And we see tools bin dot slash embed images png dot py cd dot boom. What? pwd, where are we? cd tools bin. Oh, Python. What? Oh, wrong pipeline here. exe, right? And now it should be a dot slash. I was thinking of a different pipeline. What? Bed, oh, PNG. There we go. Okay. Okay. Now we're cooking. Sandbox. Okay. There. That there is a bookshelf. Sort of. Mostly. Should we go all the way to big? Like, reasonably sure. I guess you can't see this many details since it's a little bit shrunk. I kind of want more height per shelf, actually. It's fine. It's fine. It'll be fine. So there, that's one of our images done. We should get the blocks assembled and see if we actually can fit 7 blocks in here. I think that's stage 2. Next. I don't think I want 2 different. I don't know. I've got different thoughts on this. I need to go make a block. I need to make 2 textures. So let me back up the GIMP. We're going to show it in this same file. That's what I think we're going to do. I wish I could like group and show and hide these rulers. That would be very handy. But I don't think I can. So we're going to put Because these guidelines are going to mess me up. I don't like some of these colors in here. I think we need an even darker brown. Selected this one, so we get the bucket fill similar colors. We're just gonna, whoa, whoa. Threshold. There we go. We're gonna make these very dark. A little more contrast here. And then we'll use this dark one for these shells. Boom. I kind of feel like I need a lot more than 2 pixels here. 401 to 396. That's 5 pixels. We might have to give up some of our vertical spacing above our blocks. Which would be fine, which means I'm really leaning towards getting a layout script for the different guides. That's fine. That's fine. That's further refinement. Let's just get some basic layout stuff done. Let's get the blocks in here. So the blocks. Something about layoutmath.org. It was fine. 4263. Doesn't look right. Block begins at some height, 78, sure. Block ends somewhere else, and that is not 42. That's got to be 42. I do a copy paste issue. Okay. Let's lay this out. We're coming over here, starting at somewhere. We do want some pixels in between. And we want a nice, easy to use number, like 1, 11, 10. And then we're going to go down 78 from there. So 11, 10 minus 78. 32 is 1032. Oh, no, plus. Okay, that's easier then. 1110 plus 78 is 1188. That can go from 0 to something, to what was it? Width 63. 61, 2, 3. Yeah, we've got to get rid of excess guides. So we're going to need to do some foo script eventually, so we can read in the line guides we care about. Okay, let's see here. So shelf side extrude. Cropped content. I'm just gonna feel better if I'm not wasting all this memory. Layer cropped content. Layer cropped content. Background. Okay. This guide can go away as well. Oh, no, background move. Yeah, okay. So down here, 78 or 42. So 1188 minus 42. 6, 4, 1, 1, 1, 4, 6. 1, 1, 4, 6. Then we come over 42 and 63. Is that our block? Holy smokes. Here's our block face, and then this comes up. This, oh, it does not come up. Okay, so the difference between 42 and 63. 63 minus 42 is 21. So we come in 21 from the edge. Okay. Still, 78 minus 42. 78 minus 42, 36. Okay, I guess that's not that bad. Alright, so what we're going to do is we're going to create a new layer. Should we just merge all this down? If we ever have to recreate this all, we have to recreate all of it. Basically. Or we can create an empty or group. Is there a group? New layer group. Shelf. 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 Boom. Actually, these shelves don't matter. Front face. Okay. Top, side extrusions, and then the shelves on top of all that. There. We can put this on the top if we want, but it doesn't matter. Okay, so now shelf is neatly tidied up. I think. Everything has been cropped to content, so we're not wasting tons of memory. Good. New layer group. Oh, no, not there. Bring it out. This one will be called block face. Sure. Block face. Okay. That is this thing where we go 42 by 42. Bucket. Or white. The letter will be imposed on white. We can go with like a more, a slightly cream color, like it's been aged. Maybe even a teensy tiny bit of red. No. Which means just a teensy tiny bit less green and blue. That's fine. We'll bucket with that. Just a little off white. You don't want things to be pure white. They look blue if you're painting. Okay. Then we say new layer, extrude top. So on this one we want like a wood texture color, but this is from here to here, here, and I already forgot how much this thing extrudes. Dadgum. Basically to here. I have to choose a block color. It seems like a lot of extrusion though. That's fine. Block color. We need a different wood color. I have deleted the path. I don't want to do that. There to there to there to there. Close it. Edit. Selection from path. Bucket. Fill. Okay. New layer. Extrude side. We need to remember this position is 1110. This one was 1188, right? 1146. So 36 pixels. We need to come up off of this one, 36 pixels. All the way down to here, 1188. Minus 36, 1152. Woof, okay. Polygon tool. Corner. Corner and corner. Close it. Select path. Then we need to darken this color some, so just move straight down. And fill selection. Boom, there we go. So there, that is a block. Sort of. want to make a little another thing here. So let's go, yeah, put them straight up against each other. 2, 3, 4, 5. So what's that number? So that's 68. Let's go to 70. Then 70 plus 42 is 112. Okay, select. This one we are going to make pure white, because we're going to use it for something else. Rounded corners. Yes. Radius like 5. Can I edit this, please? Thank you. 5. Oh, we really should have done that for this face as well, actually. We'll come back to that. Oh, oh, come on. Delete. Okay. We need a new layer. Base color. Okay. No, we're not in corners. Yes, rounded corners. 5. Bucket, white. Then we're going to chop off a few pixels on each side. So 70 to 75. I don't remember what this guide was for. Oh, I know what it's for, so that's fine. This one, top to is 1146.51. Okay. From this edge, 112 to 107. Lastly, from this edge, which is 1188, 1183. Okay, select rounded corner, radius 3. Delete. Okay. Now this block face. Radius 5. Delete that. Then we turn on rounded corners. Very light color. Bucket fill. Okay. Now on that side extrude, I think we need to erase a bit here. On this border. Where's an eyedropper tool? Eyedropper tool. I need this color. I'm just gonna kind of fill things in a little bit. Eyedropper. Oops, not that one. top extrusion. Just trying to get it to blend a little bit. Face. Whatever, good enough. I'm no artist. This one, I think we can just get away with erasing. Hopefully. Just a little bit of erasing. Maybe not. We can't get away with that easy. Yeah, whatever, good enough. Good enough for government work. We need to round off this corner here. Down here. Yeah, good enough. A little bit on this corner too. That's right, this is not the final art. We just want to get the idea of a wooden block. It does feel like it's extruded very deeply though. Oh well. Okay. So for this one, we need to remember certain numbers for our UV coordinates. So we're going to say the main block is 0. And this thing, which is 1, 1, 1, 0. And it's out to 62, 63, 62, down to 1188. Okay, then the block is at 69, X, Y, 1146, all the way over to 1162. No, that's the y-axis. 112. 112. Well, code or okay. And then down to 1188. Okay, so those are the two things we need there. So we're gonna save, export, hide GIMP so you can see what I'm doing. Now we're gonna go to our images text. Bookshelf is probably now wrong. UV rectangle. Block body will be at 0, 1, 11, 10, 62, 11, 88. Lock face is at 69, 11, 46, 112, and 1188. Okay. So in theory, I can now create a block. I don't remember source texture quad batch set quad color. Okay, I can. Good. All right then. All we need to do is go to the shell, re-embed our image. Okay. We're going to do sandbox. We're going to add a block, which is actually a text quad block, quad batch. Hey, Fit Writer, welcome, welcome. Hype, hype. I like hype. Hype is good. How are you doing? How are things up in Canada? Quad batch. Pretty sure you have to give a number of quads. Yes. Two. You had the TikTok interview today? Good. Awesome. It did okay-ish. It was an online assessment. Okay, okay. So what kinds of questions did they ask? Let's hear the stories. Did you have a in-person on the call, I assume? Yeah, some system design course. Yeah. As a new graduate, I would expect a lot less system design kinds of answers anyways. Okay, okay. I send a link to HackerRank. Yeah, I'm really tired of companies doing that. But hey, getting into pre-screen means that your resume was good enough to get into the pre-screen. Cool. They make you do some lead coding. I've looked at that 63 and 78 a million times, so we should know those off the top of our head. Okay. So I'm going to set this block on the bookshelf. Means we need to know the height of that top extrusion, which was 90 pixels. So there's a shelf. When we render, we want to render the block after it. Order matters. Well, good. Hopefully your pre-screening went well and you're getting the next interview. That would be great. Except texture. The same exact texture this thing is in. Set quad UV. No. UV key. Block. I don't remember what it's called now. Block body. So that is 0. We want that one to render first. And then 1 points at block face. Okay. Set quad rectangle. So we're going to take the top of the bookshelf. We'll put it on the edge of the bookshelf. That's fine for now. I'm going to score shelf.y plus the height of the scaled. Scale vertical 90 pixels. Minus the height of the block, which is 78. So basically we're taking the top edge of the shelf, which includes that extrude area. We're moving all the way down to where the shelf itself begins, and the extrude is over. And then we have to move the block up, the height of the block, so the bottom of the block is on the front edge of that shelf. I think that's how we want it. So that's XY width. $63 and height 78. Quad 0. Quad 1 will be much easier. Shelf XY, fine. But then we scale B90. We only have to move up 42. Then we're 42 by 42. This is quad 1. And lastly, block dot set quad. Okay, that one's right. Set quad color. Make it a nice red. The reason we went with pure white. So in theory, this should place the block on the upper left-hand corner of the shelf, and it should have a red border on the front face. Let's see how that theory works out. Update, render, okay. Clean and debug build, here we go. Oh my gosh, 5:15. I'd like to get where I'm laying out a 5 blocks on top and 7 blocks down below. I'd like to get where, like on the shelf itself. I'd also like to get to where the text is superimposed over the blocks. I have some text at least over the blocks. I might need some more fonts though into this game. Oh, come on. Okay. Easy fix. Has no member named X. Self.x. Shelf.x. Oh. Rectangle. Rectangle. I forgot we did that. Okay. Text quad batch. I could swear there was a convenience function for loading set color. Really? That seems odd. Set texture given the asset. That should be a convenience method. Texture quad batch. Set color. Wait. It's not like we're doing anything that we wouldn't do anyways, but why not just set quad x quad index given the asset. And basically says all textures should reference this one texture. Renderer scale W and H. That's right. Scale height. Scale height. Scale width and height. Scale height and height. Okay, scale. Oh. Deleted something. Scale height. There we go. Unused variable block width and height. Oh. That is fair. Block height. Block width. Block height. Block face size. .42. Block face size 42. Block face size. Block face size. Okay. Okay, go to our sandbox, and there things look terrible. There are options why that could be. There are a couple of little dots of red there. I colored something red. Okay. Y plus render scale 90. I feel like the Y is correct. Block. Width and height. Put this in exactly the same place, almost. Hmm. Huh. Hmm. We have used this feature before, this batch texture quad. Where have we gone wrong? There's the very light color. It's just it looks like it lines up there. Shelf doesn't look too bad when it's scaled up. It's all right, we're just doing it for layout. It's okay. So what's wrong with my quads here? Hmm. Trying to think here. Set quad rectangle. Top of the shelf. Move down. And then back up some. Huh. One hundred. 100. 100. 100. Fifty. 50. 100. 100. No locations, no sizes, no scaling. Let's remove some variables from the problem here. Let's just size them up. Fast and simple. Sandbox. Okay. Possible that our UV coordinates are wrong. That actually looks like red stuff that we want. I bet it's UV coordinate issues. Let's go back to our images text. So it's width and height, isn't it? It's width and height. Okay. Height is 78. 42, 42. 62 or 63? Look at the lines of the GIMP real quick. Yeah, 63. X of 68. That's an odd number. I thought I moved it somewhere sane, like 60. 70. I moved it to 70. 1146. I guess. Okay. So we re-embed our stuff. So we've got 63 and 78 and 42. Right. Okay. File. Ah, yes. Good old UVs. So this will look terrible until we put those other UVs back, the other rectangle sizes back in. Oh, we already did that. Sandbox. Okay, there's things. Badly done things. Boom. Boom. Okay. Now we're cooking with Pisco. Okay, that does kind of look like a block of wood sitting on top of another block of wood. Yeah, my coloring's not great. That's okay. It's just there to give us the idea. So we want 5 of those now. I don't think. Well, let's just do it. Let's just do it. Sandbox scene. Oh no, what am I saying? Just need to maybe give it more. So we'll make it 10. We'll call this current guess. Just change the name of it a little bit. Underscore block. Okay. So this is gonna be all 5 blocks in one draw call. Cool, cool. Body rect equals, or basically this. Parentheses. There we go. X, Y, Z, width and height. Okay. Rectangle for face rectangle. Face rectangle. Okay. Now that we have 10, we have a whole bunch. Okay. Block spacing. Const double block spacing equals renderer. We decided on 2 pixels, right? Scale with 2. I think that's correct. Okay. For int index equals 0, index less than 10, plus index. Index and 1. Else. Face separate quad is index. Face rect dot x plus equals block face size plus block spacing. That's actually true. Yeah, sure, this is fine. And body rect gets moved by the same amount. Okay, so that might just lay out all 5 blocks for us, fast and easy. We can hope so, anyway. Oof, it died. Let's try just a clean build. initializing the blocks with more quads might have changed my memory footprint enough to require a clean. All right, let's see how it looks. Okay, and it's still dying. Huh. Insertion failed. And underscore quad set Q index. 362. I could swear that we set something for it. Quad set equals false. Fine. When we set quad corners, we set it to true. Well, set quad corners is called by set quad. Oh, I bet I know what's going on. Maybe. Init layout test. Index, but then we have 0, 0, 0 here. That's ridiculous. Okay. Index mod 2 C equals 0 to 128 0. Who cares? 256. Go bright. Else mod 3 equals 0 index modulus 3 equals 2 255 5 0. We'll give ourselves 3 colors. Set color to C. Okay, those indexes should now work. We do not need to clean. Hey, there we go. 5 blocks. Blue, red, yellow, blue, red, yellow. Or, well, it wouldn't be yellow if we had more. Okay. Cool, cool. Now, the width of the shelf is a known quantity. Do I remember what that quantity is? No. 7 something? 760 something. Let's see, where's the layout math.org. Shelf begins, shelf ends 709. So half of 709 is 354.5. I would like this yellow block centered right over this one right here. Yeah, I think we can start to see what I'm going for here. I'm not sure that 2 pixel spacing is doing anything. Actually, I know it's not. Because we didn't add it in. Oh, we did. Lock spacing. Yeah, I guess you can kind of see that 2 pixels. It's that dark area there. Face and body got that. So okay. Alright, so obviously there's some art things we can do, but we're just doing layout, like technically laying it out. Okay, so I said 709. So if we add half the width, shelf X, shelf Y is the top of the shelf proper, like the front edge of the shelf. Shelf Y minus our block height, that's fine. Okay, what's block face size? Okay, so what we want is to change this to plus renderer scale width by half of 709, which is 350.5. Okay. Let's do it this way. Shelf X plus equals come on. Offset half of shelf width scale width by our block faces. There are 5 of them. And we need to only take half of that off. Shift back half width of blocks. Okay. Let's try that. That might center the blocks above the center of the thing. Hey, the yellow one looks pretty centered. Not bad. All right. Cool. So all this newfound expertise in this stuff. That layout doesn't look half bad. We could kind of move the Y just a little bit. Shelf Y minus equals block spacing. So basically move it 2 pixels up off the back of that shelf. Just so there's a little bit of that brown underneath the edge, and it's not like red straight into front face. Yeah, just that, maybe twice that. Does block spacing need to go bigger? Let's be honest here. Need to be 4. It might. Okay, now we're cooking. Oh, well, that offset is just a tiny bit off. So, why that offset is off is this plus this. Block spacing times 4. And these are added up and then have boom, dead center. Nice. Now, does that mean that our blocks will no longer fit in this width? That is a question we will have to answer. And we should probably start looking at that answer. Okay. By adding another guess. Guess 0. It needs even more vertices because it's not 10, it's 12. Guess what? Probably not going to have time to throw text on top of things. I'm afraid that when I calculated this block spacing amount, I should have calculated in more. Oh well. So this X is not the same down here. In our layout, wall 1 ends, column 1 begins. Word 1 begins at 19. Render scale width 19. Shelf y equals m shelf dot rectangle dot y. Offset wall and okay. A couple of visual anchors for me. Offset wall and margin. Shelf margin. Not this, yeah, okay. Shelf Y, so we're at the very tippy top. Delta y plus equals the amount we did before right here. Okay, that's not what I planned, but okay. That's equal to fix. So for y, word 1 begins at 9. Oh, at 1061. Scale height 1061. Offset to bottom shelf. Okay. So those are positions. Guess one. Two minus the block spacing. Why not? Okay. So we get a new body rectangle and a new face rectangle. I think I have a convenience method for setting a rectangle. Dot set or something. No, I just let you modify them all yourself. Okay. Dot x equals. Actually, that's fine. Body rect dot y equals that. We do not need to change the width or the height. It's already been set. Okay, oops. Minus block height, that was it. Okay, so those are both reset. Okay, this will be the fun part. We're going for 12. Start green, a blue, like 164. And maybe like a one. What did I get up there? 56, 128. Sure. Okay. If index equals 11, we add another space. And if index equals 10, we add another space. I think that's it. We're laying this out now. Current guess, what time is what? Guess 1. Right, figure out all the math. Set the texture, set the UV coordinate to the positions, colors. Alright, let's see how we did. Does it show up on shelf 1? These are the mysteries. Just about there yet. If this worked, that is going to be a great place to quit. Depending on what shows up wrong, we may try to fix it real quick. I'm running out of time for the night. Okay. Oh. Oh, yes, 0. Unbelievable. Okay. Does it show up on the shelf? Does math work? It kind of did. My color selection is crap, and there should be an extra space here. This box should be shifted over. Oh, which means it might be clipped by that thing. Ooh, interesting. I had not considered that. Okay, well, it's not 10 and 11, it's 9 and 8. Because the 10th and 11th one need to be shifted the extra. Yep. Shoot. I know a way we can cheat it, but do I want to cheat it? But still, let's fix those colors to be something slightly more garish. The green is fine. The blue, let's just, oops, 255, 255. Let's make it hideously bright. And we already have let's do a red, green, so some nice orange maybe. Maybe not so nice orange, I don't know. See, this is why we're laying out not super great art just to begin with. We're learning what our requirements are. Yeah, that does not go behind that. That's okay for now. But they do fit. So there's the word and there's the number. There's the word. I'm not sure the letters are going to show up very well. So let's go back to small size. Yeah, I might have a hard time seeing those letters. This block idea might not work. This might not work. Still, we got it all up and running, so that's not the worst. Not very many draws per frame because of the way we're doing it. Yeah, that text is going to be real small. Shoot. Well, we have to get creative. Because I do want the letters to have like a depth to them. Maybe just not as much depth, more like a tile, but the width is kind of set. I mean, I can recalculate all the widths. I don't know. We'll have to think about it. Anyway, that's kind of what we're going to be doing for the next long while as we Journal. Where are we at? We did not log anything. Tasks. Layout, bookshelf, and pixel by a pixel. Layout, blocks, you put letters on. Start laying out scene, game scene in sandbox. I would say we accomplished all three of those. Notes, bookshelf image is huge. We can put a bunch of textures in a bunch of things in that one texture. To get powers of 2. Okay. Blocks look okay. Some things we could change to make better, but not sure if it is worth it, as the letters will be very small. The letters on the face will be very small. Test tomorrow, but I don't think it'll work very well. Okay. All right, so let's see here. Sounds good. Start show, get status, get add. So that perspective blend wasn't great. Layout, we do want to keep it on our math notes. Layout the bookshelf. It's fine. Bookshelf image page. Okay. We had a minor update there. We're doing the layouts there. Image warehouse has been updated, obviously, and the images.text. Okay, so that all makes sense. So add everything. Laying out dimensions and coordinates for new bookshelf. Playing with blocks. C sandbox for testing. All right, we're gonna call it there. Like I said, art's gonna take us a bloody long time, probably because I'm approaching it wrong. But we're gonna wrap it up there for the night. See you tomorrow. Again, I'm not on Thursday or Friday, so we will talk to you tomorrow. And yeah, I think that's it. Have a wonderful evening. Bye bye.